Okay, good evening, everyone. We are going to start shortly. I just want to remind you to maintain yourself in mute so we have better quality. The today session is intended to get you started with Hadoop. Professor John Wu is going to present an introduction to the topic, and then we will try to introduce you to the next assignment, which is with BigSQL. There are some technical issues with the BigSQL in which the team of this cloud is working, and it seems at this point still some few issues have not been resolved, although some of your colleagues are able to run the script. So let's see. Let's start with the first part. John Wok, I'm giving you the ball, and you can share your screen.
Sure.
Just a second. I don't know why I cannot move it. Every time something changes. Okay. Here you go. Okay, now you can share your screen.
To share it, okay, share my screen. Okay.
Okay.
So I just clicked on it. So can you see my screen?
It's coming. It's a little slowly. Yes, now we can see it. Just expand.
Okay.
Expand full screen so we can. Okay, great. Yeah.
Okay. So let me start it now then. Hi everyone. As you know, my name is Jungwook Woo. From week 6, I'm gonna go over I'm gonna participate in discussion and take care of your homeworks. So for today, I'm gonna introduce the big data, especially Hadoop and IBM Big Insight. The contents of today's talk is what is the large-scale data set and why it comes, and what is the Hadoop and its history, and what is the 2 cores of Hadoop. And also, I'm going to introduce Hadoop ecosystem, and then I'm going to also mention what is IBM Big Insight and what's its relationship with the Hadoop. Okay, so since there are many people who knows Hadoop and big data clearly, so this is great chance for you to get familiar with the Hadoop and big data and IBM Big Insight. So this should be a very fruitful experience for you. So first of all, there has been data issues because of a large-scale data set or massive data set that is greater than terabyte or petabyte. That is because of the web data. We have too many websites. Also, we have too many sensor data that is actually related to IoT. IoT is Internet of Things. Basically, it is the sensor. Sensors generate too many data from by checking your room temperature, or your vehicle, or airplane, or the parts. Also, bioinformatics, that is to cover DNA, genome. It has like a actual massive data set. Also, social media such as Twitter, Facebook, LinkedIn, those generate too much data. And also streaming data, that is part of sensor data and IoT. And smartphone generate too many location data and the social media data. Even at this moment, many of you generate your location data to share your data with many applications. Also, online game generate many log files for about the user information and the event and then status of game. So this kind of data that generate too much data that we never experienced before. So the issue here is using the legacy approach, we cannot handle this data. So, the legacy approach, the traditional approach is like a relational database and data warehouse. Using these traditional systems, we cannot handle this data because the data is too big. Also, these data are mostly non-structured or semi-structured data that the relational database or data warehouse cannot handle because that is based on the table schema. And also, if you spend a lot of money, you can actually handle it with the relational database and data warehouse. However, you need to spend millions of dollars to find out any insight from this data that is, you are not sure how much insight you can find out by spending that much money. Okay? Because those data we normally throw out before, but now you need to use it to find out some insight. But how do you know how much insight, how much value you can find out, right? So you may not want to spend millions of dollars for this. So we actually need a new system that is not expensive but can handle this massive data set in the format of unstructured or semi-structured. So we have to remember that there are actually two cores that we should handle in big data. The first one is how you can store this massive data set. And second core you have to remember is how you can process or compute this massive data set. Fortunately, Google met this problem earlier than other people or companies because they are collecting data from many, like a website from Word, and they index it. They store it and index it and process it to make it searchable. So the Google actually around the 2004, Google published a paper to show up their technology to store this massive data set using GFS, that is Google File System, using inexpensive commodity computers. The servers that we used to use. And also, almost at the same time, they published another papers to show up that they compute this massive data set using Google MapReduce approach. Actually, MapReduce is not that new. That has been used in AI, especially, for example, using Lisp programming language. So that is not new, but MapReduce approach is actually good for data and parallel computing systems. Okay? So basically, Google made parallel computers using actually thousands of inexpensive servers. Okay? So actually, Google has had supercomputers to collect and process their data for search. So based on this publication, the paper from Google, actually Hadoop has been started in Apache open source community. This gentleman is Doug Cutting. He's a Hadoop, the founder of Hadoop, and he has been working on many Apache open source community, especially for Lucene search library, and also for the Notch, the web search engine. And after he read the Google's publication, Google's papers, he realized that those are really great ideas to handle massive data set using parallel distributed system. So he started another Apache project called the Hadoop. And this is the symbol, the icon of Hadoop. So whenever you see yellow elephant, that is actually a Hadoop project. And also the Hadoop Also, Hadoop is named by his son's toy. His son has a little toy, elephant toy, the yellow elephant toy. The name was Hadoop, so he named this project as a Hadoop. So Hadoop doesn't have any meaning. It is just the name of this toy. So if we go back to the Hadoop history again, the Doug Cutting has been working on Notch web search project, and then around the 2003-2004, the Google published the papers for about Google file system and MapReduce, and then Doug Cutting actually was motivated to start his own project in Apache using a distributed file system and MapReduce. That is made mostly to support Notch web search project, but actually it becomes a much bigger than just integrating into Notch. And also around the 2006, Yahoo hires Doug Cutting, and so Hadoop becomes actually the individual project in Apache. And around the 2007, since New York Times has a project to convert TIFF image files to PDF file, that expected like millions of the expenses, but one of the New York Times developer knew how to use Hadoop and how to use cloud computing, Amazon cloud computing. So he actually built a MapReduce code in Hadoop and make it run on Amazon EC2 using only $250. And 4 terabytes of image files are converted to PDF file in 1 day. Okay? So that is famous use case how Hadoop can be used for massive data set, such as 4 terabytes of data can be converted to a PDF file in one day without spending millions of dollars. And also around the 2008, Facebook launches Hive, that is a Hadoop ecosystem based on SQL syntax instead of using MapReduce Java code. And also Yahoo started its own the Hadoop cluster using about 1,000 nodes. Node is actually server. And also around the 2008, at the end of 2008, Cloudera, one of the leading big data company, was founded. And also 2009, the using Hadoop, the benchmark for the sorting with like a terabyte and a petabytes of data are actually sorted successfully within, for example, 17 hours. And then Hadoop Summit has been started by actually Hortonworks. And then Doug Cutting actually joins Cloudera to be a CTO to continue the Hadoop Big Data project. Okay. So those are kind of brief history of Hadoop. And then 2016 is like 10 years of birthday of Hadoop. And it has been adopted by many companies. Also, we are going to see the Spark later, but anyhow, the Spark is about to replace MapReduce by integrating into Hadoop cluster. So that should be another good the project if you go over tutorial 4 and assignment 4. So anyhow, let's go to big data again. So we can define big data as an actual framework or system. Okay? So big data is inexpensive frameworks that can store large-scale data set and process it in parallel. So there are many solutions for big data. I mean, there are many systems for big data. There could be NoSQL database or Hadoop, and Hadoop is again the one of the popular big data systems because it uses non-expensive commodity servers to build a Hadoop cluster, and it is actually a parallel computer, and parallel computer is supercomputer. So before to own a supercomputer, you need to spend millions of dollars, and only government normally own it. But now, because of Hadoop, using a commodity servers, any company, any small research lab or university lab can own supercomputers. And even you can build your own Hadoop cluster to store and run your applications. Okay, so this is the definition of big data that you have to remember. And now let's move on to cores of Hadoop. The first one is Hadoop Distributed File System, HDFS. This is nothing else but to store data in distributed way. So if you have a input file, if you have a file, you can store into a Hadoop cluster, especially on Hadoop Distributed File System. And the file should be split into multiple blocks, and then those blocks are spread out into multiple nodes of a Hadoop cluster. Initially, the default size of a block was 64 megabytes, but based on many experience, nowadays the big data company like Cloudera and Hortonworks recommended that you need to set the block size to 128 megabytes. And also, to maintain fault tolerance, the blocks should be replicated across Hadoop cluster, and default size is 3. So even though one server goes down, the other server that has the block of the failed server can take over the data set. Okay? So you never lose your data in theory. And also, Hadoop file system is a write-once system. It means that you can write once, but you cannot modify or insert the file. Okay? So it basically is for batch processing and also mostly for analysis, online analysis processing. It is not for transaction. Okay. Also, simply this is file system. So file system is mostly for data analysis, not for transaction. And also it is optimized for throughput because it is parallel system. Also using Hadoop HDFS commands, you can simply do put, get, delete the data. And you can also kind of append the data. And also the three replicas, 3 block replications, maintain the fault tolerance for durability and availability and even for throughput. And now let's move on. Second core, the MapReduce. That is actually to process and compute data, right? You know, again, the computer, the basic function of a computer is to store data and then process it, right? Similarly, Hadoop system. Hadoop is to store data using HDFS and also to process it using MapReduce. Okay, so this is the second core of a Hadoop system. And nowadays we are using Hadoop version 2. That is actually using Yarn. Yarn is yet another resource negotiator. So your Hadoop cluster, especially for MapReduce, has a master node, single master node that has a resource manager processor, and you have a multiple slave nodes that has node manager process, and it can also generate application master for each application that you want to proceed. And also, this is actually based on data-intensive computing. It means that when in the place of data, the computing task should be executed. So you don't need to waste your time to migrate data to your processor. That is actually traditional supercomputer's approach. But so the traditional supercomputer is actually processor-intensive computing, but Hadoop is data-intensive computing. Again, where data exists, the processor is migrated to compute that data. So the number of jobs can be broken down into tasks, and tasks should be scheduled to be as close to data as possible. So when if the data exists in server 1, the MapReduce should be executed in server 1 as well to process it. Again, the MapReduce is even optimized for batch processing and failure recovery as well. So Yan is actually is like the manager to schedule and manage and monitor resources of the Hadoop cluster. So resources should be nothing else but memory, CPU, disk, right? So Yan is like the manager who schedule, monitor, manage those the resources. Anyone have any question? Okay, then let me move on. So there is a concept of speculative execution that the MapReduce. So it means that whenever the resource manager detects any laggard tasks, any laggard MapReduce tasks, then since other tasks are completed their job, those tasks that are completed should work on this late job to complete it, and any winning task, any task that complete that job much earlier should be selected as a result of that execution. So you don't need to wait for the laggard task. You can just generate other tasks to do exactly the same job, and then the result of any task who completed should be selected. That is called the speculative execution, and this is part of the function that Hadoop provided. So it will improve your performance. Okay. So there are many Hadoop distributions, but mainly the Apache Hadoop should be the core, the essential for Hadoop distribution. But the Apache Hadoop is actually vanilla Hadoop that doesn't have that many functions. It only has the core of Hadoop. So if you download and install Apache Hadoop, it is really hard to install and it's really hard to manage it. But there are many vendors who enhance this vanilla Hadoop with many functions. For example, IBM Big Insight, that is one of Hadoop distribution given by IBM. Also, Amazon AWS has a EMR, electric MapReduce, with its own file system like S3. And Cloudera provide its own Hadoop distribution called the CDH. Hortonworks provide its Hadoop distribution called the HDP. And Microsoft Azure provide the HD Insight. That is actually based on Hortonworks HDP. But anyhow, instead of using vanilla Hadoop, if you use cloud computing like IBM, Amazon, or Azure, or if you download CDH or HDP, then it is very easy to install Hadoop, maybe in 30 minutes, and then you can immediately start your Hadoop project. So it's like you have a Linux, but you don't use vanilla Linux, right? You use Red Hat Linux or Ubuntu Linux. Okay, so the Cloudera and Hortonworks are like the Red Hat or Ubuntu to make people easily use Hadoop with a good GUI and installation systems. Also, there are many Hadoop ecosystems that has been added. You know, the Hadoop has been in the market for 10 years. And then, I mean, past 10 years, many companies have used the Hadoop, and then they realized that they need more functions or more systems they can efficiently use the Hadoop. Again, the Hadoop has only two cores, HDFS and MapReduce. But for example, for data analysis, Facebook invented the Hive and Yahoo invented the Pig. Those are based on SQL and easy script languages. So when you, I mean, instead of writing complicated Java code for MapReduce, using Hive, you can use the SQL syntax to make your, to process your data much easily and simply. Similarly, Pig has a script language that is simple to analyze data as well. Basically, Hive and Pig automatically convert their code to MapReduce jobs. So you can save your time to write code and to process it. But Hive and Pig are batch system. So to make it interactive system, Cloudera invented Impala, and Hortonworks invented TAS, and IBM invented BigSQL and BigSheet. Those are based on mostly MPP, massively parallel processing system. That is a traditional parallel system, but it provided interactive the performance. Okay? So that's why you are working on BigSQL project. Also for data streaming, to collect the data, the streaming data from sensor or from log file, there are the Storm and Flume and Kafka. Those are additional Hadoop ecosystem donated to Hadoop project. And also for exchanging data with the relational database, there's a Scoop ecosystem. Also for in-memory processing, these days Spark has been integrated into Hadoop cluster, and it is replacing MapReduce. So this is actually the diagram to shows the core of Hadoop and its ecosystem. Okay, so normally the Cloudera CDH and Hortonworks HTTP provide all these ecosystem. So if you download and install CDH or HTTP, you have all at the same time. So you can install it in 30 minutes in your systems. But your system should be server. If you want to install it in your laptop computer or desktop computer, it doesn't have enough resources. Okay? So in the Hadoop, in the center, there is a Pig and Hive and HBase. HBase is NoSQL DB. Also Flume and Scoop for data streaming, and for coordinate the multiple nodes, there's a Pasu Keeper, and etc. So there are many ecosystems that are supported by CDH and HTTP. If we go back to Hive and Pig a little bit more in detail, as I said, it is developed at Facebook and Yahoo respectively. It is actually, using this Hive and Pig, you can turn Hadoop into a data warehouse. Physically, it is not data warehouse, but logically, you can use Hadoop as a data warehouse because any code in Hive and Pig can be converted to MapReduce jobs automatically. So you can easily analyze data. Again, since it is batch processing, but it's not interactive, so using MPP, Impala, Tez, or BigSQL could provide interactive processing. And Hive is based on Hive query language, based on SQL syntax. And Pig Latin is the script language of Pig. And for interactive query, there is a Spark SQL, Tez, Impala, and BigSQL. And this is the logical diagram how you can build your Hadoop cluster. So for example, Cloudera has Cloudera Manager to install CDH for your 9 servers. So when you have 9 servers, using Cloudera Manager, you can immediately install Hadoop cluster to build based on which is composed of 9 servers. And 9 servers are connected through a switch. But normally the small companies or research maps start with 3 or 5 nodes to compose a Hadoop cluster. And then whenever the data size goes bigger, you can add more servers. So it is called scalable, especially horizontally scalable, because you can add more servers. Whenever the more the data, you add more servers without any problem. Also, let's go back to IBM platform on big data. IBM actually has InfoSphere Big Insight and InfoSphere Streams. The Big Insight is to Big Insight is I mean, you can regard it as a Hadoop system, and Stream is for data collection, data streaming services. Okay? So based on Big Insight and Stream, you can integrate with the big data toolkits, such as business intelligence tool like SPSS, Tableau, or Click. And that could be based on on-premise data center, or it could be based on the Bluemix cloud computing. Also, recently IBM Big Insight has been improved a lot, especially for Apache Hadoop. So it provides Hadoop and many ecosystems. Besides, for the data analysis, it supports BigSQL and BigSheets. Again, those are MPP-based interactive SQL service that can support Hive and Pig. And also for data scientists to predict future trends that you can see in assignment 4 using Spark. The IBM Big Insight provides the text analytics that is from normally Watson, and also it supports Big R, the R, especially for massive data set by IBM, and also BigSQL and BigSheet can be used for data science. And also the IBM Big Insight even provide multi-workload, multi-tenant scheduling. It means that many users can access the Hadoop, Big Insight system without any problem. Okay. So that is kind of content of IBM Big Insight that you could use using Bluemix. And also, if you take a look at the IBM Big Insight based on this diagram, Hadoop and NoSQL should be definitely the core, and then it can be integrated with a data warehouse such as DB and content management and data management service by the Bluemix. And then also Bluemix provides Spark services for data science and data analysis. And you can integrate it with the business intelligence, again, with the SPSS or SAS or Tableau. And then you can visualize the result. So same thing for this slide. So for a massive data set, you have to understand the big data analysis flow. First, you actually need to collect the data from, for example, using API service from Yelp and Google for business listings. Also, you can collect streaming data, such as Twitter data, using Twitter API or using Apache NiFi or Kafka and so on. And you can download the open data from government website. So once you collected this kind of data, you need to store this data into hard file system or Amazon S3 or IBM Bluemix Object Storage or the Microsoft Azure Object Storage or into NoSQL DB. And then using Hive and Peak, you can clean the data. You can validate data, filter it, convert it, and then you could use Hive, Peak, or Spark, or using BI tools. You can analyze or predict the data. And then the result normally should be visualized for much better insight using Click, Excel, Power View, or Data Mirror, or Tableau. Okay, so this is very important big data analysis flow. Mostly, first three diagrams are for data engineering, and the fourth one is for data analysis and data scientists, including data visualization. Okay. So this flow is very important for big data processing. And also, let's go back to the IBM's idea how you can integrate the big data system into existing system. You know, existing system should be a relational database or a data warehouse that you can see in this green box. Using the IBM streaming service or IBM Big Insight, you can collect the data from sensors or from database or from Twitters or Facebooks and from servers, and then those data can be stored into, a hard file system in the beginning, and some of them should be migrated into data warehouse because data warehouse has really good functions, including BI tools. So for example, hot data that are used now should be migrated into data warehouse to be analyzed and visualized by BI tools. And the warm data or cold data that you don't use that frequently, but that may have a value, should be stored into hard file system. Okay. So for example, a hard file system that can be part of, before Hadoop exists, you actually need to store many massive data set into data warehouse, or you need to throw away. But now, since Hadoop system is relatively cheaper than data warehouse, you can just keep them all into Hadoop file system, and then later you can find out the value or insight. Okay? So you don't need to throw away your data now using Hadoop system. Also, again, streaming system can be used to transfer data into Hadoop system or directly to data warehouse from many data sources, including IoT, okay, to be analyzed and visualized as well. Okay, so this is the the latest big data system that is integrated into traditional system. This is not only the IBM's idea. Many big data vendors also has the similar diagram. So actually, this is it for introducing Hadoop file system. Do you have any questions? This is a great moment to learn Hadoop systems. So if you have any questions.
Hi, this is Vivian. I have a question for you. If you could go back to the diagram, that was the one right before the last slide, where you showed the solution with the data warehouse and the streaming and all the different, the current kind of like extended data warehouse architecture, for lack of a better terminology. Are the boundaries of that traditionally like all contained? Like right now we're accessing IBM's cloud environment. It's got Hadoop and the big insights and all the other stuff in there. So where you have the red arrows going between the streams into the BI apps or into the warehouse, are those all in the same physical data center, or like what kind of networking do you need to have in place to make that work if your warehouse is internal but your Hadoop is maybe external? Is that something that people do?
Fortunately, the cloud computing provides a hybrid service. So if you work with the IBM or the Amazon, they will give you the solution. You can use, for example, IBM cloud computing and your data center together. But you need the switch.
Right. So when you do that, do they work with you to engineer the right capacity of your networking equipment to make sure the data transfer between your environment and the cloud isn't a bottleneck?
Definitely. You
Okay.
you need an engineer who needs to calculate the data capacity.
Thank you.
Sure. So I have a question. This is Dave.
Mm-hmm.
What I just am curious if you've seen this too. In my line of work, we work with customers to try to do these data warehouses and these grids, and it's been very strange for me because there's been, on the one hand, Google and Yahoo and others, and Amazon for sure, doing these large grids and able to do them very cheaply 10 years ago. And we find that customers struggle to support grids internally cheaply now, that the cost for them, even though the hardware is dropping like crazy, that the support for companies doing it is really not very good from our sampling. And I guess my question is, have you seen internal clouds a lot, or these days, or are you finding that the clouds are really all these external clouds, or sorry, these Hadoop clusters that are large?
For example, Netflix, instead of building their internal data center, they actually adopt the Amazon. And in theory, if you use cloud computing, after 5 years, the cost that you expend should be much higher than having your own data center. However, in real, the Amazon gave a lot of the discount for Netflix, so their price is not that higher than people expected. So the point is, many companies choose either data center or cloud computing to have their own Hadoop cluster. So it's up to your calculation. So all companies, they calculate based on their the status to choose either data center, own data center or the cloud computing service. Does that answer your question, Dave?
I guess it's just one of these things that you mentioned several times, and I certainly see it when I go shopping for hardware, that it is very cheap. But when we work with customers, their cost includes the support cost on a per computer basis, and that price is not dropping. It becomes a big part of the equation. So the cheapness is only seems to be with the cloud vendors and not so much with the enterprises. I just wondered if that was what other people are seeing too.
Got it. But instead of comparing the price for Hadoop itself, you have to compare the price between Hadoop and a data warehouse. So if you want to keep, for example, 10 terabyte data in data warehouse instead of Hadoop, that should be maybe 10 times or 50 times more expensive. That is the point. But installing Hadoop on your data center or cloud computing, that are different issue. Because there is the comparison between Hadoop itself.
Okay, thank you.
Sure. Any other question?
Yeah, this is Vivian Hunsley again. So, can you hear me? I'm sorry, I wasn't sure.
Yeah. I can hear you, Vivian.
So, Dave was bringing up a good point because, in my particular organization, we've been considering, extending our capabilities and, cloud versus, cloud platform where we install the products ourselves versus a full-blown environment that's fully supported, including the whole suite of tools, and then also looking at doing it internally. And the one part that I struggled with on estimating what the cost might be for the cloud environment is based off of just how do you know how much data you might be downloading, because it looked like some of the services were based off of, you could have however much space you need, but then, and you add to it as you need and you pay for that space, but then you also pay upon download. So like if you have a web-based application that a lot of people are accessing and you're doing analytics, and are there chances that people are going to just be downloading stuff and do you have to consider additional controls to prevent people from exceeding limits or something like that? I mean, how do you estimate what that volume might be if you've never even done it before? You don't even have anything to base it on.
Okay. Vivian, actually, that is beyond the discourse. I mean, that is the question beyond the discourse, but let me try to answer it. Each company has like a system admin or CIO or CTO. They should know, for example, how much data should be generated. Yeah, so for example, every year if your company generates 1 terabyte of data, maybe you need 10 servers. It means that for next 3 years, you need 30 servers, right? Roughly. If every year you need 10 servers for 1 terabyte, and you expect next 3 years you need 2 terabyte more data, then you need 20 more servers, right? So you need a total 30 servers. So those are very rough calculation, but this is how people estimate how many servers you need.
Right. So I got that part of the equation really down pat, right? We know how much data we might host out there in the cloud.
Exactly. If you can estimate
the on download aspect of it, if you don't know what tools you're going to have that are, well, even if you do know what tools you're going to have that are accessing the data on the cloud, what's this download charge fee? It sounds like you're almost getting charged for letting people use your environment. Maybe I'm misunderstanding the cost model.
No, but the So calculation is very easy, but you definitely know how much data you need to use for the next 3 years. But as you said, if you don't know, then the cloud computing is the best option because Amazon, the Microsoft Azure, they have a dynamic resizing service. So depends on how many data you use. Sometimes it becomes 30 servers. If there is less data, it goes down to 20 servers or 10 servers. So there are many options. But again, if you want to start like a big data project, you need many experts who can calculate and estimate how many data you need for next 3 or 10 years. Plus, if you don't know how much data you have, you may want to start with the cloud computing that can dynamically scale up and down the number of nodes. Do I answer your question?
Sort of. I mean, I have all of that, I have some of the equation figured out. It's just not understanding how this charge per access thing works because I don't know how you can make an estimate based off of assumptions, and obviously you don't always know that your assumptions are accurate, but are there any tools that help you understand the type of, that data is being downloaded from certain types of applications rather than it just being done on premise, like BigSQL has the computing going on at the database level, not sending data back and forth between the end user and the application.
Again, you need the expert first who understand the systems and to calculate the size of data, and then someone should help who knows your domain. Then I'm pretty sure you can calculate what kind of system, what kind of how many nodes, and if you need on-premise or cloud computing service. So I mean, there are too many business, too many companies. They have their own status. So only the company itself should know how to build the system.
Thank you.
Sure. Any other question? Again, this is a really good chance for you to know about big data, Hadoop, and Big Insight, and others. So please feel free to ask me any question.
If there are no more questions, just your clarification regarding the assignment number 3. Can you hear me?
Yes, I can hear you.
No,
yes.
Because I was in mute. I don't know if I can. Okay. Yes. Today they were issued with the cloud environment we are using for the assignment number 3. They've been fixing the issue, but the service is intermittent. So some people can run all the code, can create table, can query, can do whatever they want. Some people cannot, and this is going on and off. I would suggest wait until tomorrow that they will restart the system again and follow the instruction posted in the classroom. If additional help is needed, we will schedule either more individual session or group session. It depends how things evolve, and because some of you already have started working in the assignment, I have a few feedback, and they find this quite straightforward. So maybe all of you, or maybe not all of you. That's why I don't want to predict how this is going to evolve. Just I want to alert you that they are issued with the system, and if you bug to the issue by tomorrow, hold on, don't waste your time, just read the instruction and the other material. In the meantime, I want to just point out why we are doing this assignment in BigSQL. According to the presentation Professor John Wop just delivered, you see that the Hadoop ecosystem is, if you count the number of different components, is intimidating. And you understand that practically in a single class, there is no chance we can explore this in deep. So we pick up, let's say, one of the most relevant components of the Hadoop ecosystem, most relevant for a data scientist, data analyst, which is BigSQL, and which is manageable in 2 weeks to get hands-on experience in parallel with learning more about the different components and the different use of these components in the Hadoop ecosystem. And my suggestion is, in the discussion, try to discuss whatever you are interested, but always try to go more to the analytical part, because you understand in any project related with the use of the resources in the Hadoop ecosystem, you have involved different type of people, starting for system engineer, data engineer, which is going actually to build the data structure for you and calculate all the data and transmission and all the engineering part, and the data analyst and scientist will have to work together with him in order to get the architecture he will need to do the analysis of the data. So that is my suggestion regarding the discussion. Try to discuss as much as possible, because this is the best way to learn, because it's too much. Just look into a single diagram, you see how much it is. And we still have time for the hands-on experience with the BigSQL. I hope everything is going to go okay with this. Just few words. Any question up to here? Just few words regarding the course organization. We announced this in the beginning of the class. So myself was teaching the first part of the course, and Professor John Wall is teaching the second part of the course. What I'm going to grade is finishing grading your assignment number 2, the first 2 discussions, and I'm running the group project. Professor John Wall is going to run the course week 6 to 11 with discussion and the 2 assignments, which are assignment number 3, which is in BigSQL, and the 4 on Spark. So just to remind you how the organization is. So you know who is grading you, who is responding your question, and the only thing I'm doing for the whole class is I have to schedule this meeting and record them and to post the recording in the classroom. Any questions? Here with us is Scott. Scott was the lucky one who was able today to run in the cloud portion of the assignment number 3 successfully. So we asked him to stay here, but actually I would say my suggestion is, if something doesn't work, hold on until tomorrow. We will be updating you in the status of the service with the BigSQL in the cloud, because let me clarify something. This is different cloud. It's not Bluemix. For one reason which maybe you don't realize, in Bluemix, the update of Big Insight make more difficult the access of BigSQL for us. So in order to get exactly what you would need as a data analyst and data scientist, and not burden you with data engineering work, we choose this solution. And hopefully we will be able to do in this cloud. Otherwise, we always can return to Bluemix, but it's a little more burden to do the work with BigSQL in Bluemix. So this is all I have for now. Anyone, question, comment? Well, if no more question, keep working. I like how the class is going up to now, except few exceptions. So let's keep working the same way. And have good evening. Bye.
Okay, see you guys.